Okay, moving on to activity 1-3. Draw diagrams for equations. So now we've got a little practice drawing diagrams for given equations. And as I stated at the beginning of the lesson, we use tape diagrams for two purposes. One is to represent the relationship between quantities, and the second is to use them to solve problems. So here we're going to do both. It's direction state. For each equation, draw a diagram. So we're going to draw a diagram and find the value of the unknown. So here, in each of these equations, we've got a variable, x in equation 1 and y in equation 2. So find the value of the unknown means we want to find what x and y represent. And then it says find the value of the unknown that makes the equation true. So before we go any further, I want to talk to you about what it means for an equation to be true. So for something to be an equation, it just means it's a statement that contains an equal sign. And the equal sign means that the value of the left side is the same as the value of the right side. And this means the equation's true. So if we look at this first equation here, on the left side, 3 plus 2 has a value of 5, and on the right side, 4 plus 1 also has a value of 5. So this equation is true. Now let's look at the second one. We have 5 times 3 on the left side and 8 plus 7 on the right side. So on the left side, the value of 5 times 3 is 15. And if we go over to the right side, the value of 8 plus 7 is also 15. So this is a true equation. It's a true statement. Let's look at the next one. 6 plus 7 equals 3 times 4. So if we evaluate this, each side of this equation, 6 plus 7 is 13. On the right side, 3 times 4 is 12. So this is not a true this is not a true equation. This is false, and I can indicate that by making a slash to the equal sign. So when we're drawing these diagrams, we want to find out what is the value for x that makes this equation true, and what is the value for y that makes equation number 2 true. So let's start with drawing a diagram. And what I'd like you to do actually is pause right here and try to draw a diagram for each of these on your own, and then we'll come back and review. Okay, so hopefully you paused and did this. I know some of you just kind of want to follow and write in the notes as I take them, but to get a benefit from this, you should be trying these on your own first. So our first one, 18 is equal to 3 plus x. So 18 is my total, and 3 plus x is what I want my tape diagram to represent. So there's two terms here, so I need to make a tape diagram that has 2 segments. And I'm going to label this one 3, and I'm going to label the longer one x. And I made x the longer one because I know that whatever x is, it's going to have to be quite a bit longer than 3 in order to be equal to 18. And then these 2 segments combined represent the value 18. So that's my tape diagram. A variation on this, I could have made the x on the left and the segment containing the 3 on the right, but I just kind of drew them in the order they are in the equation. Diagram 2, 18 is equal to 3 times y. So again, for multiplication, I think of 3 groups of y. And again, remember, y just means some number. I don't know what it is yet. So if I want to draw a tape diagram that represents 3 groups of y, I'm going to draw a tape diagram that has 3 segments. And I want to make them kind of equal because each one is equal to y, groups of y. And remember, I don't know what y is, but I know that these are all, y represents just a single number. So each of these segments represents the same value. And then the total is 18. So there's my tape diagrams, and now I want to use them to solve my equations. And solving means find what value of these variable, the letter, makes the equation true. So you could use the tape diagram to solve them, or some of you might just prefer to use the equation itself. You can intuitively kind of think, well, what number plus 3 equals 18? And that's really what the tape diagram represents as well. So one thing I could do is if I take away the 3, that just leaves the x. So if I take away the 3 from the 18, that's going to leave the value of x. And I have 15. So to make this equation true, x has to equal 15. And then I can check it. Is 18 equal to 3 plus 15? Yeah, that makes it a true statement, a true equation. All right, let's come over to equation 2. 18 is equal to 3 times y. So I see 18 is split into 3 equal groups. So one way I could figure out what y equals is divide 18 by 3. I know that 18 divided by 3 is 6. So it appears that the solution to this equation is y equals 6. And again, I can substitute that then back into my original equation and see if I get a true statement. And I do. 18 is equal to 3 times 6. So there's my solution for each of these equations.